So, hello everyone. So, this is that particular last experiment in those set of DC experiments. This is binary DPSK. D stands for differential phase shift keying. Okay. What does this differential? We had BPSK fine. Here also you can see ones and zeros being transmitted as 0 and pi. Okay, they are being transmitted 0 and pi. Remember, this is not minus pi and plus pi. 0 and pi is what they are sending. Okay, so BPSK or QPSK may need you to have a synchronized transmitters and receivers. So synchronized means both of them should be run by a common clock, right? How do you do that, by the way? Having a common clock at transmitter and receiver? No. Basically, that means your carriers at both the sides should be synchronized. You usually use a PLL for that, right? You usually use phase lock loop for that thing, and it is supposed to be very tricky. And usually, whenever there is a frequency shift due to Doppler or time delay spread, usually synchronization is lost, and you end up making bit error rate goes poor. So it is good to have a coding scheme which can be uh, demodulated asynchronously without having to know the knowledge about the phase information at the transmitter. Okay, so DPSK is one such scheme. A differential phase shift keying is one such scheme. So how do we do the DPSK generation? By the way, it's a differential thing. Okay, it's a differential mode. Suppose that means say the previous value you had sent was current value is one, previously you had sent a one. Based on that, if at all the values are same, you send a 1. In case the values change, you send a 0. And if they do not change, you send a 1. They do not change, you send a 1. They change, you send a 0. They do not change, right? You send a 1. See, do not change, you send a 1. Do not change, you send a 1. And at receiver, based on this only, you know how they have been transmitted. The trick is you have to get your first bit correct at receiver. You get your first bit correct. So that is possible by coming for a common agreement, going for a particular special sequence can be used, and then afterwards easily the values can be decoded or demodulated. So how is it, by the way? Is it easy? The demodulation easy? Yes, the demodulation usually includes a simple method. Okay, so here is for you a binary DPSK. Okay, so what was important thing here is it's a non-coherent scheme. So those schemes which need you to have synchronized phase, right? A synchronized clock between transmitter and receiver, they are called as coherent modulation schemes, or coherent demodulation. This one does not need you to know the exact phase information at the transmitter clock. That's why it's a special scheme. It's a non-coherent orthogonal modulation technique. Okay, so here is the generation. So let us go to the MATLAB program. Okay, the corresponding MATLAB program here. Okay, so where is it? Yes. So here is your DBPSK sequence. So for this particular program, I have used this particular ready function MATLAB object. Okay, DBPSK modulator and DBPSK demodulator. Some random data has been generated of length 10 just for symbolic purpose. Okay. Then afterwards, step is a function, by the way, used for modulation. Okay, so here you can see earlier I used the function PSK mod for FSK mod. They are already functions. Here this is comm dot the so there you can use help to explore much of these options available. And then afterwards the entire thing has been demodulated also. Okay, so I will not be making much sense if you do not know the theory about this DBPSK or most of the differential schemes. Okay. So I would suggest you for all these four experiments you have to go through the textbooks. Okay, so I understand there was lockdown, and I don't know how much effort you had put or on these particular things, but at least for the sake of at least out of curiosity, once again revisit all these topics. The programs are here being displayed. and I told you I will share this programs also with you. Okay, so kindly go through the videos once again, run the program on your own, and go through the theory and make the changes and observe the output to validate whatever that has been told in the textbooks. Okay. So that's that. Bye.